Question 10. The contact process earns its name from the contact of the two gases on the surface of a solid catalyst to produce another gas X at 450 degrees Celsius. The reaction reaches a state of dynamic equilibrium. Dynamic equilibrium is a state reached when the rate of the forward reaction is equal to the rate of the backward reaction. Okay. The first question says identify number one X. Okay. So here, we should know that the two gases that the question mentions are sulfur dioxide as well as oxygen gas. So these are the gases that are used in the contact process, and these two gases react together to form sulfur dioxide, and it is this X here. So the X is sulfur dioxide. Number two says the catalyst used. So the catalyst used, you could either write platinum, or if you want, you can say vanadium 5 oxide. Okay, right. Question B. One of the reacting gases is a pollutant. State the source of this gas. Remember, I said that the two gases are oxygen as well as sulfur dioxide. Between the two, the one that is a pollutant is sulfur dioxide. So the source of sulfur dioxide is by burning sulfur in air. So when you burn sulfur in air, sulfur dioxide is produced. Another source of the sulfur dioxide is by burning sulfur compounds in air. Let's say the sulfur compound, which is called zinc sulfate. When the zinc sulfate is burned in air, it produces zinc oxide plus the sulfur dioxide. So this is another source of the sulfur dioxide. Okay, so here I wrote by burning sulfur in air. Question C. Construct an equation including state symbols for the formation of X from the two gases. So what we'll have is something that is very simple. So we have sulfur dioxide here reacting with oxygen. Okay, so here and there. So this half hour signs here represent that the reaction is reversible. So the product is sulfur dioxide. Balance there. This gas, this is gas, and this is also a gas there. Okay, let me write this properly. So we have that. So this is the way that you write the chemical equation. Question D. To produce X, manufacturers avoid increasing the temperature. What does this show? What does this suggest about the thermal nature of the reaction that produces X? Remember, I wrote my reaction to be something like this. So we'll have that. Okay. So here my answer was that it is exothermic. So if manufacturers were like to increase the temperature using the Italian's principle, an increase in temperature would cause the position of equilibrium to go to the side where the excess heat is removed, and this side is towards the decomposition of the sulfur. So it will go in this direction, meaning that the yield of the sulfur dioxide will reduce. So that's the reason why manufacturers avoid increasing the temperature, because the reaction that produces X is exothermic in nature. Question E. The desired product or for the contact process is concentrated sulfuric acid. Outline how X is treated to finally obtain the sulfuric acid. Okay, so we have X as being sulfur trioxide. So the first step is something that is very simple. Number one, we will we will dissolve this sulfur trioxide in cold concentrated sulfuric acid. Okay, so the first step is dissolving the sulfur trioxide in cold concentrated sulfuric acid. So this forms a product that we call oleum, and the formula of this oleum is like this. So we have, okay, sorry, let me start now. Alright, so the formula is H2, S2, and O7. Okay, so this is the liquid that will form. Right, then step number 2, this liquid, the oleum, I would it to be something like this, is diluted. It is diluted with water. Okay, so this produces the sulfuric acid that we want. Okay, so these are the steps that are taken to finally obtain the sulfuric acid, and I wrote in an organized way here by saying sulfur dioxide is dissolved in cold concentrated sulfuric acid to obtain an oily liquid called oleum. The oleum is then diluted with water. Okay, after that, sulfuric acid is produced. And my last question says, give one commercial use of sulfuric acid. There are a number of uses of sulfuric acid. Number one is that it is used as an electrolyte. Okay, right. It is used as an electrolyte in dry acid accumulators. Okay, something like that. And if you don't like this, you can also say the sulfuric acid is used to manufacture explosives. Alright,